So the question comes up, why should we develop 25G base T? Because today our use cases, our leading application for 25 gigabit Ethernet is really the cloud service provider, and that class of customer is really not using base T today. So the answer comes, who's going to use base T? It's those users that are still largely using base T today, which is our enterprise class of organizations. Enterprise servers today are still predominantly using 1 gig Ethernet, 1000 base T. And as those customers are making the transition today and over the next couple of years to 10 gigabit, they're more likely to use 10G base T. It gives them that same familiarity and infrastructure that you're used to, and it's easy to migrate and have mixed environments that have both 1 gig and 10 gig. And as we give a roadmap to 25G base T and to 40G base T, we're giving that enterprise customer a path to the future, whereas 10 gig will last them over the next few years, and 25 and then 40 gig will be, say, several years out beyond that. Each of these technology life cycles will probably last us, say, 3 to 5 years. But we're taking smaller steps now, rather than going in decades, 1 gig to 10 gig to 100 gig, we're taking smaller steps that makes it easy to roll out the next generation, both in product development, product cost, product qualification. 25G base T is actually very synergistic to 40G base T, both in terms of the standard development effort and in product development. So in 40G base T technology, we've made already a strong reuse of 10G base T technology while adding some optimizations. And the experts in the field are seeing that they can drop in 25 gig as part of the same standard, just scaling the data rate. That also makes product development in the future easy as well, because the PHY developers can use that same technology for 10 gig, 25 gig, and 40 gig base T. So we're now suddenly seeing in the market a great pull for some intermediate rates of base T, somewhere between 1 and 10 gig. And we have a leading use case that's really driving that, and that is 802.11 AC wireless access points. And as different generations of AC access points go to market, they're needing higher and higher bandwidth uplinks into the enterprise network. A wireless access point very commonly uses today 1000 base T as its uplink into the network, and the device is usually powered over that same cable using power over Ethernet. So access points that are in development today are going to need more than 1 gigabit of uplink bandwidth. And rather than running multiple cables to access points, we can reuse that existing cabling that's already pulled in the office spaces, Cat 5e and Cat 6 cabling, and we can use the technology that we have today, again, just generally technology that was developed for 10G base T, and we can get a lot more data bandwidth out of that Cat 5e cabling. So speeds that look very well suited to wireless access point applications would be around 2.5 and 5 gig, and that technology is really going to reuse a lot of technology that we have in 10G base T. So again, it makes it much easier to develop the technology, to standardize it, and also makes product development go smoothly too, because a PHY product developer can easily reuse the same chip for 2.5, 5, or 10 gig.